I don't know how many of you joined us at the beginning of this, but I did provide a great deal of thanks and acknowledgement to a number of individuals as well as groups. And in this particular situation, a partner of ours, Fluree, suggested some case studies in regards to a client that they've worked with. And I'd like to present to the group Kate Giovacchini. Sorry about that. She's the co-executive director at Arizona State University. And also joining Kate is going to be Andrew Johnson, a solutions architect, giving some clarity on the ways higher education is adapting to their information needs and with this changing student population. And of course, as the title states, delivering student-centered credentialing outcomes requires a data-centric approach. So I'm getting a little punchy late in the day here, so I'm glad you guys are able to take it from here.
Yeah, thank you so much, Steve. And Kate Giovacchini, you almost got it, but guess what? I'm used to it. At my high school graduation, there was an issue. So we're good. I am so thrilled to be here. Like you said, my name's Kate Giovacchini. I'm the managing director of an initiative called Trusted Learner Network. We're going to talk a little bit about that here at Arizona State University. And I am so happy to introduce my colleague from Fluree, Andrew.
Yeah, hi, everyone. I am Andrew Johnson. I'm a lead platform engineer at Fluree, but in this case, we'll really be speaking about my work doing solutions engineering alongside Kate and alongside this sort of specific, really fascinating use case and the requirements it has for sort of data centricity and a lot of the sort of semantic standards I think you all will care about. So we're excited to talk a bit with you guys.
All right, so Andrew is driving our slide deck, which is, it's always fun to be a passenger. So let's go forward. All right, digital credentials as keys to future success. So we are here to talk about digital credentials. Let's go ahead and go to the next slide. Credentialing being a very sort of hot topic in a lot of different areas, right? When we are thinking from a higher education US perspective, what is a credential? Okay, here are a couple examples, right? These may seem familiar to some of you, many of you. We have a college diploma here, right? We have a transcript. We have a Starfish Swim School award indicating that Casey did an excellent job at adult stroke improvement, right? These are all digital, or these are all credentials of a type, right? They're an assertion that a person has achieved a thing, right? Achieved either a learning outcome, achieved a mastery of a typical thing. And in the higher education industry specifically, we look towards diplomas, which are a very old technology, right? I mean, I can even see here, this is my diploma, by the way. We can see here that it looks like there's some gold lettering in the A, S, and U, right? These are indications of veracity and indications of validity. They don't translate well into a digital environment in which people are moving around a lot more. They're reskilling more often. And they may need more sort of granular credentials in order to be able to get a new job, to seek a new educational opportunity. Let's go ahead and go on to the next slide. We'll talk a little bit about where sort of digital credentials are now. So there are many conveyances of digital credentials. These are largely sort of shaped by the student information systems that hold and process the work of help of getting students through education, right? So we might see things that are very traditional to the paper transcript we saw, a name, an achievement, who it's conferred by, what date it's conferred by, right? And we get trust by appearance. We get trust by sort of direct exchange, so by a sealed envelope. What we're thinking about with the Trusted Learner Network and what we partnered with Fluree to work on was imagining what a digital credential could be, right? So what do we gain when we have the opportunity to append a lot of additional metadata and create a lot of additional relationships with that data? So what do we get when we attach something like a syllabus or a description of a course? How about the skills or the competencies that are learned at a more granular level in a course? What about the framework in which that credential exists, right? Perhaps it's a program, perhaps it's an accreditation association. What about assessments, rubrics, instructors? So we're thinking about what do we get when we increase the amount of data and create data centricity that focuses more on the learner and less about the process of design. And then on top of that, where do we get when we can do trust through code and governance rather than trust by appearance or through exchange? So let's take a look at the next one. Again, thinking about this digital credential, and Trusted Learner Network and ASU cannot take credit for this, right? We're existing in a large ecosystem of digital credential technologists, ed tech companies, higher education providers, all different kinds of educators that are interested in engaging in this space. So we know that digital credentials, as we reimagine them, can become easier to share, and they can lower the barriers to new opportunities. We know they can be difficult to lose, right? Because they can be digitally stored in a secure, safe environment instead of maybe hung up on the wall. We know that we can reduce fraud using cryptography and verifiability, and also sort of data that defends itself. And we can also, like we said before, we can enrich high quality information into these credentials to make decision-making easier. Let's go to the next one. Where we find challenges are, I don't think either uncommon or not surprising, right? So when we go out and we engage with colleagues in our space, or we engage with employers, we say, what we hear is, is this technology feasible for us to develop, or is it out of reach? Right? Can I trust it? Does it function the way that we think it does? How does shifting my paradigm around how I treat my credentials change the way I do business? Right? We are also sort of constantly focused on paying attention to who we could potentially leave behind, right? So what inequities could be expanded? This is sort of central to ASU's mission, where we measure ourselves by whom we include and not whom we exclude. We are aware that sort of current digital credentialing processes are extremely effective for some, very, very difficult for others, create barriers. So part of this will always be, how do we get better? And then when we engage with folks that are doing the credentialing, we are also hearing a lot about, what do we lose if we change? What do we lose as far as money, control, or value when we reconsider the way that this data is structured and reconsider how data sharing and exchange and sort of data value creation is thought of? Okay. So that takes us a little bit to the Trusted Learner Network. So the Trusted Learner Network is something ASU began iterating on in 2018. And I was able to join as a product manager. And now I'm extremely thrilled to be the managing director of this initiative. But let's go to the next one. So at its core, the Trusted Learner Network aims to be an independent, self-governed, and distributed organization that serves as a utility by housing records of learning that can be shared at the consent of the learner. So some key pieces to pull out of there, right? So the idea of de-siloing data. So if we can bring data, credential data into a third space, it could be more manipulatable, more accessible, and more consentable by learners, right? They also get the opportunity to curate, share, and share data, right? In a completely different way than the way that it is done before, right? Which is requesting a verification or a transcript and receiving that from each institution you have, and not really having a way to combine those to sort of reckon them together or to engage with those in a curation way. Let's take a look at the next one. The way that we intend to do that with the Trusted Learner Network is sort of through this three-pronged model, right? So we believe the key to this is a community. So there's a community of digital credential technologists, like we said, ed tech companies, and credential issuers, right? This is a situation where if we are not all moving forward towards this vision of digital credentials, we're going to create challenges for our learners. Central to the TLN's model is governance. So we believe we need contributors and co-designers that are building the trusted rules to power the Trusted Learner Network. How are credentials issued? How is consent managed, and how can learners, appeal if they need to? Underlining all of this is a technology that we envision and have enabled through Fluree as a secure repository of credentials, right? Designed for learners to exercise their agency over their achievements. Let's go to the next one. And very briefly, here's sort of a design paradigm that we imagine, right? So a digital credential repository that is wrapped by governance, security, and access layers that are both easy to iterate upon from a development standpoint, and also designed in such a way that the data can sort of defend itself and learners can do the type of consent that we want them to be able to do, right? Very clearly stating, I would like to share my credentials with this entity or this individual and not others. Yeah, and then Andrew, we'll just go quickly through the principles as well, which will be the next 2 slides. So these are the sort of guiding principles that we imagine for the trusted learner record, right? Or trusted learner network. So stewardship, right? We've talked about learners being able to select, stack, disclose, and send as they choose, as well as consent, right? These are hand in hand, that the learner defines the sharing and revocation of sharing, not the institution. We strongly believe that identity is a key component to this, not just future identities, but also to accommodate identities that exist, to make it easy for the learner to engage with their records. And interestingly, assertion is obviously a huge component of this, right? That issuers own the responsibility of accuracy and authenticity for their records, which is key for a lot of different reasons when we're speaking to our issuers. Let's look at the next slide. So those are the principles built for our learner. And then we've talked about equity a little bit before, but to build on that, right, we believe that this solution needs to be open sourced, right, not dependent on the purchase of proprietary or commercial products, built to share, built for an opportunity for many types of iterations, right, for issuers to interact with. We also believe that interoperability is really key. And this was a huge connection point with Fluree and with the whole paradigm that Fluree builds on. Equity, right? So we build the center justice, equity, and agency to serve all learners, both in a technology and a governance perspective. So that involves us engaging with learners, engaging with the types of issuers that were represented, and also engaging with folks that have sort of special expertise in the technology and equity space. Finally, we do believe that immutability is key to equity, right? So durability and auditability through this distributed ledger technology means that if your institution of learning shuts down, right, that you are not left stranded without really any way to prove the learning that you've received. I'm going to talk a little bit longer and take you through a couple of the iterations that we had building the TLN over these past 4 years. So let's take a look at the next slides. Experiments and design is a great way to describe it. We were sort of given into 2018, we were sort of given the goal, go out and build things. What works? Incubate. And here are some of the findings that we've had. So let's go to the next slide. Cool. So we started out looking at Hyperledger Sawtooth and trying to design based off sort of strictly blockchain-backed design paradigm. We started with a reverse transfer use case with the community college. We were extremely excited about how completely configurable Sawtooth was from the ground up. And the developers that we were working with in our small team were absolutely salivating at the opportunity. And then about 6 months in, we said, wow, this is a steep learning curve and we have a lot to learn. And there was a lot to sort of build up from the ground up. So concluding that pilot use case, we rolled into one with the CRM. So the ease of integration and actionability of the data was attractive, right? So CRMs are very understandable, but also very sort of business case focused in the way that the data is structured and the way that the data moves. So we kind of struggled to fit credential data into that customer data model. From there, what started getting us on the path that we are on today is in 2020, we began with a relational database architecture and utilized like graph database technology to create relation data. It was a familiar design and dev path. We built it from scratch, but ultimately we ended up finding it difficult to achieve the sort of object level security and access control that would scale, right? So if we were coding in access to sort of data at the student level or at the course level or at the institution level, it soon kind of turned into something that really wasn't functional for us to work with, which takes us forward into our key entry point. So I'm going to talk a little bit about what reverse transfer is. I'm always excited to talk about reverse transfer because I think it is one of the coolest things that we do as a higher education institution. And then what I'm going to do is I'm going to turn it over to Andrew, who's going to tell us a little bit more about how he conceived of this, the connections that he saw, and we, both sort of come out agreeing that Fluree was a really great choice for us, specifically the way that the knowledge graph data functions. So let's take a look at the next slide. Oh, reverse transfer. I am genuinely excited. Okay, so reverse transfer is a function of higher education institutions, typically 4 years. And what happens with reverse transfer is we have a student, and that student attends a community college. So that's that line one, that relationship one of student to the community college. The student attends the community college for a certain period of time. And when they're ready, maybe after a year or two, maybe after a certain number of credits, they decide to transfer to a 4-year institution. Maybe they're ready to start their engineering coursework. They've done a year and a half at the community college, or maybe they've accrued 45 credits from several community colleges. So boom, they go to their 4-year institution and they begin their coursework there. What happens is that over the time that the student is at the 4-year institution, they accrue credit at the 4-year institution that can then lead to them receiving an associate's degree. So associate's degrees are fabulous. They are 2-year degrees. And we have like kind of a preponderance of evidence that indicates when a student receives an associate's degree, they are more likely to finish a 4-year degree. They have something in their hands. So even if they stop out at the 4-year institution, they have an achievement that they can use to parlay into further economic benefit, for jobs, for opportunities. So associate's degrees are fabulous. So what reverse transfer is essentially this process that goes between 3 and 4. So 3 is where a 4-year institution pushes credits back through a consent agreement between the two institutions and the learner, pushes credentials and credits back to the community college so that when we hit number 4 here, the community college issues the learner an associate's degree without the learner really having to do anything other than consent to say, yeah, please share my credits back to my community college. I would love to receive that associate's degree when I'm ready. So I always add number 5 in here, which is the bachelor's degree or the 4-year degree as a cool terminal stop for this process. But that's reverse transfer sort of in a nutshell, right? And what we're seeing here is, let's go to the next slide because we can just envision it. This is the application that we've been building. Let's go to the next slide. So this process really is essentially about a 4-year institution sharing course data back. And that course data is actually kind of complicated, right? So it's at the level of the learner, and then it comes in at a course level. That data needs to be sort of manipulated, combined, and sorted through pretty aggressively by the community college in order to make sense of it and to award a degree. So things like Elasticsearch with multiple parameters, sorting tables quickly and easy was really crucial for our reverse transfer community college administrators. Let's look at the last page. Fabulous. So we can see here, when we look at a student, and this is not a real student, but when we look at a student, we can see the classes, we can see the grades, the credits, but what we can also see here is all the sort of additional metadata that can help to make really informed decisions. So this is sort of the front end. This is sort of our business use case, why we're here. I'm going to turn it over to Andrew, who is our sort of solutions architect to help center this conversation around data centricity. So Andrew.
Yeah, thanks, Kate. And I'll try to jump in sort of right where you left off. So just as a sort of preface, and Fluree was brought in because we really sort of shine. We produce infrastructure software that does data management, where the entire data platform is built on semantic standards. So it's for use cases where we understand the need to have data that can interoperate between systems, to have data that can be machine readable and self-describing, But specifically in use cases where we're thinking about that data as, you know, in motion, as operational, we're thinking about it as data-centric, needing to be operationalizing applications sort of across a wide range of use cases, or with multiple producers and consumers of data, data that's sort of constantly in motion, even as the insights are being generated across data sets. And to do all that, we bring some other pieces of technology that enable the sort of stability, the sort of security and trust that really enable the sorts of values that I think a lot of you understand around semantic data, around linked data, self-describing data. But when we need to think about that from the perspective of enterprise data management and data centricity for effectively, you know, an operational influx database. So just obliquely, I just want to speak to the fact that I think data centricity can mean a lot. And for the context of this talk, I think it means two relevant things for what it does for reverse transfer. The one is how I just sort of described it. We're talking about enterprise managed data, but we're talking about needing this data layer to fundamentally sit at the center of a variety of different producers, consumers, and application profiles of data, not least of which are sitting in between, you know, all of the students who stand to benefit by having verifiable, provable credentials that ultimately could end up in a wallet. So there's that sort of data centricity. I'll talk to that first. I think the second piece of data centricity that's really critical for reverse transfer is that ultimately we want the data that describes student achievements to exist in an interoperable, semantically described vocabulary, you know, built on the same sorts of RDF standards, built on, you know, RDF schema, et cetera. So at the moment that the student gets that data, has it portable, has it self-verifiable, that they can then take it and obtain value from it wherever they go with it, into other data ecosystems, into hopefully a future that makes it more valuable to students, for students to own this exact sort of data. And in all of these cases, there's concerns and questions that we find we need to ask that can be described specifically for the reverse transfer situation, around not just, you know, not only around these concerns aren't entirely relieved by relying on the promises and the standards for semantics. They need additional layers that provide security, integrity, and trust, if nothing else. So I'll speak a little bit about how we thought about this for reverse transfer specifically. And I have to change my own slides now. So I spoke a second ago about this sort of use case need, but to sort of prompt it a bit further, when we're talking about a sort of data-centric architecture in this one specific sense of literally a data layer that needs to have many-to-many relationships with consumers, producers, applications, et cetera, there's questions that we need to start asking. So if there's multiple different entities that are actually producing and updating data, how do we maintain security and trust around that data? We're no longer the only person who is in charge of every single interface with that data. There's multiple interfaces potentially out of our control. We might own that data. It might sit on-prem for us, but there are data stakeholders who should have a right to update that. For example, ASU is managing this data, but the community college system has a variety of positions of stakeholdership to this data and deserve the ability to add or update data themselves. We also understand the value of having sort of semantically linked data here, whether it's for the vocabulary for the credentials itself, or for the ability to draw insights across data sources. But we're not talking about static data. We're talking about operational data that's being manipulated by humans and machines. So what does it look like when that data is shifting? How can results and insights be reproducible? How can we guarantee sort of provenance of shifts in data state over time and return to earlier sort of snapshots of data when we're issuing queries or building out insights? So the main sort of point that we want to draw here, and what I think both Fluree cares about a great deal as a sort of data management platform software company, but also what we care about a great deal in implementing the solution alongside Kate and the TLN team, is that for data centricity to exist around for operational data, and to care about student outcomes or student-centered outcomes here, we need to think about semantics, and we also need to think about how to vouchsafe that semantically described data with security, integrity, and trust. So in the case of security, this one is actually somewhat obvious for us in terms of describing the problem, right? We lose a significant amount of value if we have to silo all of this data behind an API. It's not a single app that needs to participate with this data. It's not a single producer or consumer sort of flow that needs to participate with this data. But if we can't rely on the typical perimeter security of a typical sort of like application-centric architecture, how do we actually ensure that we have the same sort of security, not only around data leakage of personally identifiable information or sensitive information, but managing access in a data-centric architecture? Around integrity, again, it's a matter of wanting to build the sorts of insights that semantically described data, self-describing data make possible, data that's interoperable across systems makes possible. But how do we audit those data? How do we audit that data and reproduce insights if the actual data itself is in flux because it's operational and it's being manipulated constantly by applications and by users? And then when we talk about trust, it's really a matter of just, again, not being the only interface of interactivity with this data. What does it look like when I'm not the only one who updates data, when my application might not be the only one that updates data? What does it look like to be able to prove who issued what and to trust those identities? So speaking, and I'll try to just speak because we're coming up on Q&A, so I'll be a little bit oblique here, but we can, if there's more questions about it. Fundamentally, what we've decided here is that the standards we want to implement, the sorts of vocabularies that make this possible and that help students arrive with data or finish with data that will ultimately still be valuable for them, the sort of data that's readable by multiple machines, all of this can be answered by the things that a lot of us already understand, the sort of promises and the standards and implementations that come with W3C standards like RDF, JSON LD, RDF schema, inferences by through ontologies, etc. But what we found we needed was an additional set of technology here that could back that and could provide into this sort of data-centric delivery, or the data-centric architecture we're delivering, these pieces of security, integrity, and trust. So security. One of the ways that we manage security is by enabling the sorts of permissions that might have existed previously at an application-centric API layer in the data itself. What we find is that by being able to embed permission policy as data in the data layer and also describe it semantically, we can take the sorts of relationships that a lot of us understand by having RDF-shaped data, but we can actually use them to enforce really granular permission policy. So, for example, we can ask questions like, not just when building insights and linking a student to assertions, to achievements, to the institutions who might have issued those assertions. We can even set up permissions that say, you should only be able to query a student if they're linked to an institution by that institution having issued assertions to that student. At the point when we can leverage this RDF-shaped graph data, but use it to evaluate relationships, we have something like that we like to call not just role-based access and control, but relationship-based access and control. It also means we can establish permissions that are true to the data itself. And then on top of that, we can build an entire ecosystem of several applications that can participate with the data. But because the data itself is describing its permissions, we don't have permissions that are really ultimately tangential to the data and built around an application profile instead. What we have is sort of data that understands how it itself should be exposed and surfaced. We can guarantee that there's not data leakage, and we can also build several applications without needing to sort of re-silo that data every single time we do it in order to secure it. From the perspective of integrity, again, it's really important at a moment when, especially if you're generating insights across several data sets, to know what to do when, or know how to resolve the issue caused by data shifting out from under your feet as you're trying to establish certain baselines, as you're trying to prove out that at some moment in time, the data proved certain results. For this and a variety of other reasons, what we do is we shape the data as RDF shaped, sort of natively semantic data, not just at the point when we're resolving a Sparkle query, but actually behind that data itself at this sort of immutable ledger backplane. When we go and at the sort of fundamental source have, and I hesitate to say blockchain because it's really not a, the sort of blockchain that would vouchsafe for a cryptocurrency. But when we have something like blockchain shaped data, and that data is also RDF described, we have the ability to index data not just by the sort of subject predicate object relationships that we're used to in graph data, but also by time. it becomes possible to reproduce results because you can actually query every single moment of time as if it's a database in and of itself. And I forgot to mention with security, but I can come back to this later if people are interested. We think really carefully about identity from a perspective that would never be where we can enforce identity at the message level itself. So when we can bypass an API because the message itself is cryptographically signed, we have sort of this additional layer of being able to prove out that no message in this data-centric architecture where we know messages will be coming from a ton of different angles, we need to make sure that we can guarantee identity without using the sorts of proofs of identity that we're used to in application technology. And then finally, trust. And this comes down a lot more to not just trust that someone who issued a claim should have access to issue this claim, but trust that because we're not the only person updating the data, that we know if we see some data state change that we did not expect, that we can prove back exactly who issued that. The ability for all of at the sort of ledger level behind all of this data, the ability to prove out exactly who issued what, and to prove that with 100% cryptographic guarantee, and to effectively natively sort of self-audit the history of changes to any particular fact of data, any node that's been updated with various predicate object pairs over time, to be able to have effectively a ledger or an audit trail looking back at this blockchain and find out every sort of state change and who issued them at any given time, provides the sort of trust that we need when, again, we're all sharing data that sits in between a variety of different platforms and a variety of different users who have what we commonly think of as sort of admin level access. And let me just quickly round this out because I want to speak more about what the semantics here provide. And a really easy way to do it is by talking about the actual semantic spec that we use for these credentials. It's called the Comprehensive Learner Record. It's an RDF schema described vocabulary. It's produced by IMS Global, who has as its stakeholders and contributors and sort of members of the working group, amongst others, Kate, who's on the call with me, but people who are sort of experts and implementers of this sort of across the array of sort of academic spaces. But what I really mean to say is it's very clear that something like a portable record should have should participate with a semantic vocabulary that allows it to, especially in the future as we see these ecosystems grow, become more valuable to a student because it can participate in more systems and can be sort of natively understood and self-described as it goes from system to system. It's also very clear that portable credentials for students require the sort of integrity that has made it sort of best practices for these credentials to be backed by public blockchain offerings often. What's harder is when we're talking about operational data, which is what I think I wanted to circle back to as we round this out, because we're talking about really dynamic nested data that's produced by several different issuers, grows over time. And when we're talking about a normal blockchain solution, we're talking about a scenario where that becomes very, very difficult to dynamically change, very difficult to update for the learner themselves, and becomes fundamentally incapable of powering the sorts of applications that we're talking about with the reverse transfer app, because we need data that can actually function dynamically and power application profiles. But it also becomes very difficult to manage as an enterprise. And for a variety of reasons, if not only for the if for nothing else, for the sake of students, for student data privacy, et cetera, there are good reasons for enterprise institutions like ASU to want to own this data, even as they make it surfaceable for students, even as they share that data with other custodians and stakeholders, even as they produce these sorts of data-centric architectures that allow for these wider arrays of variability for semantically described data. And so what we found is that we need something like the security blockchain offers. We definitely need the values and promises of semantic data, but we need to do it in a way that allows for that data to continue to constantly be in motion, and in a way that centers the student, even as it centers the data. So I will stop there. I think we've gone 5 minutes into the Q&A bit, but I hope that gives a good sense of the problems and like interests that Kate and I have, and some of the ways we've looked at trying to tackle those through semantic standards, but through some technology, some neat technology too.
Awesome. We did have one question come through on the Q&A real quick. Here, I'll throw it up on the screen for you.
Oh no, Leonard Jacuzzo at SUNY Fredonia Buffalo asks, how do you handle the Federal Education Right to Privacy Act, FERPA? Oh, Leonard, it's a gotcha. No, FERPA is a U.S. law that was designed in the 70s, right, to prevent institutions from sort of releasing data about students without their permission. So, as a digital credential community, a group that are working towards this, we are sort of in dialogue with the folks at Department of Ed that help to manage FERPA. And as we move forward, we sort of constantly re-engage this question. But at its core, there's a couple of components to this, right? Which is number one, the application, and let's leave the application aside, and let's say the data structure is really designed around student consent, right? And FERPA is the same way. So FERPA is designed around the consent of the student. Only the student can sort of consent to share data. So we are operating from the position that because this is a consent-driven design, that we are acting within the capacity of FERPA.
And I should clarify, the consent piece has a really neat part in what I was talking about earlier with leveraging the sort of natively linked structure of this RDF data, along with these data embedded permission policies. One of the things that we've implemented as a sort of access policy itself is in terms of sharing this data out to potentially to institutions who didn't already issue assertions for that student. A really sort of easy policy would be that the student's record of consent for their own data could easily be a piece of data state context at the data layer that could be used to evaluate whether that access should be granted. And what's neat about this being data driven itself is that it doesn't mean that we have to reseal or reissue keys for the sorts of data at the point when that student issues consent. We quite literally could allow the student to just update their consent. And even that like Boolean in the data layer that goes from false to true on that consent would be enough to then guarantee access to the same identities using the same cryptographic keys, et cetera, who minutes ago had queried for data and couldn't get it. That very second that data changes, the context for the permission enforcement changes. It becomes a really dynamic way of allowing for data stakeholders to manage access to their own data, even if they're not writing those sorts of permission policies themselves.
It looks like Mike Sullivan, Principal Solutions Architect, is very interested in hearing about how Solid could play a part here. Andrew, could you speak to that?
Yeah, so I mean, and there might be pieces of what Solid is doing that are particularly interesting to Mike. I think the piece that immediately came to mind when you mentioned this is this idea of sort of data pods where individuals can effectively keep a sort of like personal database of their own credentials, things like vaccines, things like student credentials, obviously in this case. And I think that at the point when a student is issued a credential and the proof of that sort of the proof is included along with it so that it's self-verifying, and that credential is backed by all of the sort of guarantees around trust that we sort of just described. I think that credential should be able to go anywhere. And if especially, I know the sort of traction that Solid is getting in Europe, and I think there's no reason to not want there to be a multitude of ways that students can sort of save and manage their own verifiable credentials. I think that when we're talking still at the point of the enterprise management of the data that goes into a set of verifiable credentials, we still there's still some need to have a sort of operational data management layer that can do both semantics and security. Again, once that results in a student having portable data they can take along with them, by all means, it should go into something like Pod.
Okay, we have another comment. Oh, hard to see this whole one. Here we go.
Yeah, Kate, I'd be interested to hear you. I mean, I assume that the sort of IMS Global working group has thought a lot about the like international transportability of the CLR described data. I don't know. I'd be interested to hear what you said about this, or thought about maybe not this initiative specifically, but thoughts about the global like stakes of CLR.
So okay, this is a great question. So thank you, Andrea Prego, European Parliament, fabulous Luxembourg. So we try to keep an eye on what's happening with Europass and specifically around the digital credentials and learning interoperability. It is well within our design parameters and our aspirations to create. I don't know if it's about the TLN really extending across borders, but to me, it's more about handshakes, right? So we envision a future where many of these networks will need to work well together in order to enable our learners to really move around both their countries and their worlds with the credentials that they need. So, I mean, I do see this approach as being applicable across borders. I also see a huge amount of complexity that we need to simplify in order to make that work. And I see that from the perspective of working with administrators inside of my own institution, right, that are responsible for meshing international curriculum standards, assessments together. So I see this really as a data, sort of a data interoperability question. And once we figure that out, I feel very strongly that this technology paradigm can back us up into creating what I imagine would be, for your learner journey or mine, when I move to Luxembourg and I'm ready to become a technologist in Luxembourg, that my credentials from Arizona State University and my engagements with my community would then be able to transfer. There's just a lot of complexity that we get the opportunity to figure out. And open, I would love to communicate more about that. If you're interested, please either drop me a line or go to tln.asu.edu, and I'd love to be in touch.
And I would just mention too that at Fluree we actually, Andrea, I'm not sure if you're familiar with the Human Colossus Foundation or their work around the sort of carry spec. We do a lot of work with them and have clients who layer the sort of data that they manage in Fluree on top, or layer on top of that a lot of the sorts of internationalization, standardization that's provided by groups like the Colossus Foundation.
Thank you again. Appreciate all the insights. I think what we're talking about here is that behaviors have to change associated with how data is being handled. These problems have been persistent for a long time, and they're trying to be solved with other policies. But this is a new way that allows those individuals that have those credentials and have that information, that they can provide that access, and it's moving in the right direction.
Thanks for the opportunity to speak with y'all.